English classes, you probably talked about partitives, right? A loaf of bread, a bunch of bananas, and so on and so forth. Now, but in chemistry, we don't talk about those kind of partitives, but we have a special kind of partitive we use in chemistry, and that is known as the mole. And now, in this video, we're breaking down various explanations of the mole and various constants, including the Avogadro's constant. So stay tuned and keep your attention focused. Now, basically, first of all, we have to talk about the history of the mole. Now, when chemists and scientists discover that most matter, they are often very tiny, and as such they have very negligible masses, they decide to begin to use different methods to extrapolate and help us to relate the mass of the real mass with the relative mass. So that basically means that when they found out that you cannot work with the real mass of atoms, because that would be very small. That would be the order of 10 to the minus. That would pico and femto and so on and so forth. That would be 10 to the minus 9, 10 to the minus 10. So that's the order of the masses of those atoms in grams or kilograms. So now we have what is called the relative mass. And then this relative mass is basically when you take one element, say carbon 12, and carbon 12 is basically a particular type of carbon. The reason why I put 12 behind it is that carbon 12, there are also other forms of carbon. So for us to know that we are speaking specifically about a particular type of carbon, we call it carbon 12. So and that carbon 12 is very abundant. So another example of carbon is carbon 14, and this carbon 12 and carbon 14, they are known as isotopes, which I explained in the previous episodes of crash course in chemistry. Moving on, now that carbon 12, most scientists use it as a benchmark to understand and compare the masses of different and various other elements. And for example, we have like over 100 elements. I think 109 or so. That was the last count. Who knows? They keep discovering and synthesizing new elements. So who knows? We could have gotten to 120 by now. So now we'll talk about this relative. And whenever you hear the relative means that something is compared with another thing. So and then we have what is called relative atomic mass, RAM. That's the short form of relative atomic mass, and that simply implies that since scientists were not able to accurately determine and conveniently determine the real masses of elements, they just express these masses as relative. So, for example, if the mass of hydrogen is let's say for example is 0.0001, and then the mass of carbon is 0.0016. So what we talk about relative mass is basically the mass of each of these substances divided by the mass of one atom of carbon 12. So for example, this hydrogen, if we're talking about in terms of carbon 12, for example, or let's talk about in terms of hydrogen, because hydrogen is the lightest element. So if we talk about in terms of hydrogen, what you do is you just divide the mass of that element by the mass of carbon 12. Let me explain. Now basically what that means is that we'll be dividing 0.0016 by 0.0001. So when we have this long array of zeros cancelling each other, we're left with 16 with 0.16 divided by 0.1. That's 16. So that will be 16 units, and that is known as the relative atomic mass of carbon. Carbon. Yes, I'm correct. So nowadays we can also make use of carbon 12 as a reference. So basically, carbon 12, the relative atomic mass of an atom is defined as the number of times that the mass of one mole of that atom is as heavy or heavier than 1/12 the mass of this carbon 12. So that is basically the ratio between the mass of one mole of that atom and 1/12 the mass of 1 mole of carbon 12. Now before we move forward, let me quickly explain what mole means. And a mole is basically a substance. Is the amount of particles in a substance that contain the same amount of particles in 1/12 the mass of carbon 12. So and then 1 mole of a substance in Avogadro's number is known as 6.02 times 10 to the power of 23. That's 6.02 times 10 to the power 23. That's called Avogadro's number, and it stands for atoms, it stands for molecules, it stands for ions, it stands for every particle which we can use to express our elements. So now moving on. So I said earlier that 1 mole is the amount of substance containing as many elementary particles as the amount of atoms in 1/12 the mass of carbon 12, and it's good for us to know that carbon 12 has a mass of 12 grams. So 1/12 the mass of carbon 12 will just be 1. So you basically divide it by 1/12 the mass of carbon 12. That will give you the relative atomic mass. But relative molecular mass, we talk about molecules here, not atoms. So it's still similar to relative atomic mass, but then we talk about molecules, which states that the relative molecular mass of an atom of a molecule or a compound. So because a molecule can also be a compound too. So and when they are of the same element, they are often called molecules, and when they are of different elements, they are called the compounds. So the relative molecular mass of an element or a compound basically is the number of times that the mass of that compound or molecules is as heavy or heavier than 1/12 the mass of carbon 12. So we are still defining in terms of carbon 12. That is basically the definition of relative molecular mass and relative atomic masses. Then moving on, let's talk about the mole a step further. Now, Avogadro's law was set up to make us understand the fact that each of these particles they have an amount that can be measured as a benchmark. So and that is 6.02 times 10⁻23 particles, and those particles could be atoms, could be molecules, and could be ions, as I stated earlier. And the reason why these things were able to be discovered is that you can use mass spectrometry to serve as an appropriate and credible evidence for these numbers and laws. Because when you make use of mass spectrometry, so basically what that means is that you are basically making use of simple instruments to help you understand what matter is composed. So and that also supports the values we use for our relative molecular and relative atomic masses. And I must note here that relative masses, they are not always whole numbers. Sometimes they are often involve decimals. They often involve decimals because of the phenomenon of what is known as isotopy and so on and so forth. So then from the mole we have what's called the molar volume and the molar solution. So what that means is that molar volume is basically the volume of or space covered by any substance at standard temperature and pressure. So let me talk about standard temperature and pressure. What that means is that standard temperature and pressure is there are two conditions in which the temperature of that matter is at 273 Kelvin, or rather 0 degrees Celsius. So this is known as standard temperature, and then we have standard pressure, and that's also 760 millimeters of mercury. So what that means is that the mercury, when the amount of mercury is supported by the air column in a barometer is 760, that is the standard pressure, and when the temperature is 0 degrees Celsius or 273 Kelvin is the standard temperature. So that is how we know a molar volume. And then molar volume at these conditions is known as 22.4 decimeter cube, or 22,400 centimeter cube. So what this is trying to say is that anytime you see a gas at these conditions, whenever the temperature of the gas is 0 degrees Celsius or 273 Kelvin, and whenever the pressure of the gas is 760 millimeters of mercury, that means that automatically the volume of one mole of that gas is 22.4 decimeter cube, or I can say 22,400 centimeter cube. And then we also have what's known as molar solution. Basically, molar solution is basically when you have 1 mole of a substance of a particle inside 1 dm cube of matter. So that is known as molar concentration or molar volume. That is the molar volume. Molar volume is the volume of the substance or chemical in 1000 dm cube of a solvent, and that solvent could be water and so on and so forth. So basically, let me do a little bit of calculation. For example, you know that the molar volume of oxygen is what? That will be 22.4, because the molar volume of any gas is 22.4 dm cube. So and then if we have to find the mass, the volume occupied by 8 grams of oxygen. So we just express a direct relationship and say, since the volume of 16 grams of oxygen, which is 1 mole of oxygen is 16 grams. So that means and that's 22.4 dm cube. So what will be the volume of 8 grams? So we'll put a question mark here, or we'll call it x, then cross multiply. That will be 8 times 22.4 will be equal to 16 grams times our unknown volume. Let's call it x. So when we divide both sides by 16, cancel, we have our x will be 11.2 dm cube, 11.2 decimeter cube. That is an example of the type of questions you'll be asked to. This looks simple, but it's very, very common in chemistry examinations. So thank you for watching.